Jai Hind and welcome you all. I am Professor Devendra Singh taking the course on machine design, and this is our fifth lecture in this module. And the last lecture we have discussed about the stress strain diagrams of various materials and comparison on the basis of the carbon content. We have compared the high carbon steel, low carbon steel and medium carbon steel. We have also compared the stress strain diagrams for the plastic material, brittle materials and the ductile materials, etc., etc. Here today we are going to discuss the points. We will start with the simple stress strain diagram for mild steel. Then we will come to the material properties. Then we will discuss the various types of the loads we come across during our analysis and design, and then various modes of failure under static load. Then we will discuss if the theories of failure if time permits. So, what is simple stress strain diagram for the mild steel? So, this is the specific stress strain diagram for the mild steel. So, here it is sigma, that is the stress, and this is the strain. This is this point, this is a single point in case of the mild steel, which where the 3 points coincides, the elastic proportionality limit, elastic limit and the upper yield point. And then the next point here, this is the just below the upper yield point, then this is the lower yield point, then this region is the strain hardening, and where the molecular rearrangement, atomic rearrangement, reorientation takes place, and material or mild steel will regain its resistance power against the deforming load, and this is again start rising. The curve stress strain diagram will start rising, and it will reaches to the ultimate point, the most the highest point, and corresponding this is called the ultimate point in tension. And after that the plastic flow will start and knacking will take place, and this is the fracture point, right? And the actual curve, actually this is the true stress strain curve for this material up to the fracture point. So, the points, various points that we have discussed in the last lecture. Y stands for the upper yield point or upper yield point in tension, and YL represents the lower yield point, and then this is U is the ultimate point, and F is the fracture point. So, this is the specific stress strain diagram for the mild steel. A general stress strain diagram for the ductile material we have discussed in the last lecture, that is a simple like this. This is a general curve for any ductile material. Now, the material properties. So, material properties primarily we can classify in 3 categories: the mechanical properties, physical properties and the chemical properties. So, we should come to this chemical properties, which are the properties which indicates the chemical reaction, and like toxicity, flammability or corrosion, resistance, or whether the material is oxidation prone, or it offers some resistance against oxidation. So, this is this all these kind of the properties are will be considered or will come into this chemical properties. Physical properties, which signify the physical state of material, that are those are the physical properties, and the mechanical properties which are of our interest. Here mechanical properties are the are of our interest. So, these we will discuss few important mechanical properties and physical properties and chemical properties in this lecture. So, one we have chemical, as far as chemical properties is concerned, and the last lecture we have discussed about the selection of material for the impeller of a uh, centrifugal pump in a sugar industry, as sugar cane juice is acidic in nature. So, we have to select non ferrous material to avoid the corrosion, otherwise it will dissolve the impeller in the sugarcane juice after some time. So, these are the significance of the properties a designer consider when selects a material for a particular application. So, mechanical properties like strength, ductility, malleability, resilience, toughness, hardness, elasticity, etc. These are few important uh, mechanical properties designer come across during his selection of material and analysis. Uh, then physical properties like density, thermal conductivity, electric conductivity, melting point, viscosity, surface tension, etc. Then chemical properties are like radioactivity is a chemical property, yes, acidity or uh, alkalinity, chemical composition defines, or in fact chemical composition affect the chemical properties. Atomic bonding affects the chemical properties. So what type of the bond is there, that affects some property, that's why that's affect resulted in the properties the chemical properties of एटॉमिक बॉन्ड की वजह से जो स्ट्रेंथ मिल रही है, दिस वी कैन कंसिडर, उसको हम केमिकल प्रॉपर्टीज में कंसिडर कर सकते हैं. कोरोजन रेजिस्टेंस इज एन important property. Similarly, here we can use the corrosion resistance and the wear resistance as a mechanical property in this category, in the mechanical property. So, strength, as far as strength is concerned, so we have three we will discuss later, and the next in the coming forthcoming lectures. So, strength, first we have discussed this is SYT, that is yield point in tensile or yield strength. Then second strength we have discussed, that is ultimate point in tensile or the ultimate tensile strength. Then strength we consider, this is endurance strength. And similarly, corrosion resistance or wear resistance. So, we consider fourth one is the wear strength, if we consider it as a strength, the resistance of material to resist against scratches or against wear, that may be considered. But primarily these are the three we will consider as a strength. So, SYT is the maximum stress which can be induced in the material up to the yield point, and SUT is the ultimate tensile point or ultimate tensile strength. So, this is the maximum stress which we can induce in the material up to the ultimate strength. And as E, this is endurance strength, we will discuss in detail. This is the maximum completely reversible stress induced in the material, so that we can get the infinite life of that material. Means the component you design survive for 10 to power 7 complete reversals or more than that. So, these are the strength. Ductility, ductility is the property uh, by virtue of which a material can be stressed into the thin wires. So, this is called the ductility. So, copper, aluminum, these are having good ductility. Steel is also having a good ductility. Malleability is the ability of a material to convert in the seat. अगर किसी मटेरियल को ठोका जाए और उसको हम एक सीट के फॉर्म में बिना क्रैक हुए कन्वर्ट कर पाएँ, so that is a good malleable material, or the property is called the malleability. Resilience, resilience is the energy the material can store in it up to the elastic point. So, if we go back in our uh, in this if we go back, so if we go back, this is the elastic point. So, up to the elastic point, the area under this stress strain curve, in fact the strain energy is half sigma into epsilon. uh, all of you have learned this strain energy. in your previous course on the strength of material. So, this is the area, this is resilience. If it is more, if it is more, then you can induce more stress, and as soon as you remove the deforming load, the material will be able to regain its original shape. So, this property will be useful to the material you select for the spring. स्प्रिंग में डिफॉर्मेशन चाहिए हमें, और डिफॉर्मेशन के बाद जैसे ही उसको डिफॉर्मिंग फोर्स हटाते हैं, उसे कंप्रेसिव या टेंसाइल फोर्स हटाते हैं, सो स्प्रिंग अपनी ओरिजिनल पोजीशन में आ जाना चाहिए. So, resilience is a property which you can consider a critical property for the material which should be used for the spring. Next, next property is the toughness. So, is toughness is the energy stored by the material up to the fracture point. So, the complete area before fracture, this is called the toughness. This is called the toughness, the area. So, as this toughness may be transverse toughness, may be torsional toughness, may be considered or may be understood, may be perceived like a rigidity. So, the material should be tough for those materials which is having a critical application. Uh, we can think of the shaft, we can think of a pressure vessel which is subjected to the pressure. So, the material which should be able to bear the maximum possible uh, stress without fracture. If fracture takes place in a pressurized vessel, it can cause very heavy loss. So, toughness is the energy which is absorbed by the material before fracture. This is toughness. So, these are important properties. And now, the next property is the hardness. Sometimes, and the tools, cutting tools, we need to have, sometimes we need to have some surfaces which should have good wear resistance. So, hardness is the property. Hardness is the important property. So, hardness is the ability of material to resist against the scratches or indentation. So, this is called hardness, and the application, what kind of, what, where you will find the application of this property in bearings. The surfaces should be hard. When we consider if there bearing, what is the utility of bearing? Bearing का काम क्या है? Bearing एक ऐसा मैकेनिकल एलिमेंट है जो लोड सपोर्ट करता है और रिलेटिव मोशन वाले पार्ट्स में सपोर्टिंग मेंबर की तरह इस्तेमाल करते हैं, एंड इट is used to support the load as well as to reduce the friction. And if friction is the important part to, along with to take up the load, so the surfaces must have the sufficient hardness. So, this is the property we consider in the races of the bearings and the surfaces of the balls of the ball bearings. So, this is important property there. And in case of the cutting tools, so if we want to cut something, so we can only cut the softer thing with another tool which is having the hardness more than that what you want to cut. आप जिस चीज़ को काटना चाहते हैं तो उसे उसी चीज़ से काटा जा सकता है जो कटने वाली चीज़ से हार्ड हो. So, in case of the machining, the material for the cutting tools should have sufficient hardness as well as toughness. Then elasticity, this is another important property. Uh, as we go and as we move ahead, and we will discuss various types of the modes of the failure. So, we never want to get a permanent deformation in a component which we a designer design. If I want to, if I design a shaft, अगर मैंने एक shaft design की है, so उस पर load लगने के बाद deformation is there, but I will never permit the I will not like to have this shaft to deform up to the point where it will be under where it will be subject to plastic deformation. अगर प्लास्टिक डिफॉर्मेशन हो जाएगा शाफ्ट का तो ये वापस अपनी शेप में नहीं आ पाएगी और नेक्स्ट साइकिल के लिए it will not be able to perform the function with the desired efficiency or with the desired effect. So elasticity in the material is also an important property from the designing point of view. Similarly, there are physical properties like density. We want to have transportable materials, so materials should be having a low density, so that mass per unit volume should be low. So we will consider the density. Sometimes we need to uh, dissipate the heat as soon as possible, or the heat should flow through the component we design. So thermal conductivity should be good. Similarly, if you want to flow a current and so electric conductivity should be high, or if you want to insulate it, so it should be a good insulator. Melting point, if for example we want to make some product through the casting, so the melting point should be low. But on the other side, if we are designing something which is subjected to the high temperature, and we don't want to get it melt or get not affected by the high temperature. So melting points in that case must be high. So on the basis, the designer will select the material, what is the melting point of it. uh, and viscosity. uh, Viscosity is another physical property. If there are a number of applications where we come across, like in lubrication, so viscosity plays a very important role in case of the lubrication. So the flow should be viscous or non-viscous, or it should offer the resistance to flow, or it should make a film. For example, in the journal bearings, so we need to form a uh, film between journal and the bearing. So if viscosity is very low, then it will be very difficult to form a film and to reduce the friction or to avoid the metal to metal contact in the journal bearing. So this will be an important property in case of the journal bearing. Surface tension is another physical property which you can find applications and in number of cases, and capillary action, etc. Then these are the radioactivity. So this is something which we use in our nuclear plants. Then acidity is another issue. If something is acidic, then the designer will select the example we have discussed earlier, alkalinity. So the material, like I like to give an example of the water for a boiler. To generate a steam, we use a simple water. So we try to maintain the pH value. So it should not the acidic nor alkaline alkaline. So if it is more alkaline, then the tubes of the water tube boiler may get scaling, and this thermal or heat transfer rate will be affected, and the rate of steam generation will be affected only due to this chemical property alkalinity. And the chemical composition and atomic bonding and corrosion resistance. Corrosion resistance we have discussed earlier in case of with the example of the impeller of centrifugal pump in the sugar industry, to pump the sugarcane juice. So these are the chemical properties, these are the physical properties, some few properties I have discussed here, and the mechanical properties I have discussed. All these properties a designer has to consider when he she is to make a appropriate selection for particular design. So material selection is a critical step to make your design cost effective and popular, to to make it popular and efficient and effective. So there are a number of properties are available. A designer has to consider as per the application. Whenever the application requires some more properties, we consider during the design for the selection of materials. So in the design, there are various types of the load, and primarily the mechanical loads can be divided in two groups. First is static load. Second one is the dynamic load. So, what is a static load? A static load is that load which does not change in its direction or in its magnitude. It neither change its direction nor magnitude with respect to time. That is called the static load. And a dynamic load which may change its direction or it may change its magnitude with respect to time is called the dynamic load. I am discussing here just a basic definition of static load and dynamic load. When we will design the components, and we will discuss in detail what is the meaning of the static load and dynamic load. So, what is static load? So, as far as the load time curve, this is the static load. So, this is the pickup time. इतने समय में इसने मैक्सिमम मैग्नीट्यूड को इतने समय में ये मैक्सिमम मैग्नीट्यूड एंड देन इट विल रिमेन सेम इट रिमेन्स it comes constant with respect to time changes, but there is no variation in the magnitude of the force. And if it is a positive direction for the load, it remains positive, it is not moving on the negative direction. So this is in the category of the static load. Next is the load time diagram for the dynamic load. Here load is in positive, it is not going on the other side, it may go in the other side also, but it is varying the magnitude for at this time, this is the magnitude at this time, this is the magnitude at this time, this is the magnitude at this time, this is the magnitude. So, as time changes, the magnitude of the load varies. So, this is considered as a dynamic load, and dynamic load may be it may have some constant values. So, for example, if I consider this, it will be come across us when we discuss the design against the fluctuating load. So, if it is there, then suppose this is sigma and this is time, and it is having this is sigma, uh, this is sigma, this is also sigma, sigma A, this is also sigma A, having the equal value, but this is in the positive direction and this is in the negative direction. This is tensile in nature, this is tensile in nature, and for this duration this will be compressive in nature. This is compressive in nature. So, this is also considered as a dynamic load. So, I think it is clear what is a static load and what is a dynamic load. So, a static load which is having a constant value with respect to time, accept some time that is a pickup time of the load. You place जो आप बाट को तराजू पे रखते हैं, जितने समय में वो तराजू पे रखा गया उसने इफेक्ट दिया, that is a pickup time of then it will be a constant, that is static load. And if there is any kind of variation whether in magnitude or in the direction with respect to time, that is called the dynamic load. So, and after that this mechanical load we can classify as static load or dynamic load on the basis of the effect. It if it creates the tension, then it is considered as a tensile load. If it creates the compression contraction in any object or in any material when it is applied and compression is there, then this is called the compressive load. And if it is in the direction tangential, then this is called the tangential load. And then if it creates some bending, so this is called bending load, and if torque, then this is called the torsional load. So this is tensile load. If this is a member, it is subjected to, this is compressive load. And if this is a block which is fixed here, and tangentially I apply some load here, this is tangential load. And if this is a block and I apply some bending moment, so these bending moments we consider as a bending load. Or here we have a beam, which is a simply supported beam, and this is this. So this is again subjected to the subjected to uh, the bending, right. It will bend like this, right. This is elastic curve. Then this, if this is a shaft circular in section and it is subjected to a torque, then this torque is called the torsal moment. So for today's lecture, uh, this is uh, this is all. And tomorrow we will discuss about the effect of the centric load. Further, we will continue with the types of the load in the next lecture. Thank you very much.